Hi, this is slideshow number 1. So watch the slides, answer the questions that are on Canvas, type it up, turn it as a Word document. Should be a pretty easy assignment. I hope you enjoy the slides. So Unit 3 and 4, we're changing gears. We're going from more meteorology into kind of geology. We're going to be talking about tectonics and gradation. Tectonics is Unit 3. Tectonics are those processes that want to build up the Earth's crust, the mountain building forces. Gradation, that'll be Unit 4. Those are the processes that want to wear everything down, make everything look flat, like northern Texas or Kansas. So this slide right here, I was up in Canada when I was in a rock and roll band, touring across Canada back in the 1980s, a long time ago. And I took this slide, it was like minus 60. It was brutally cold in the wintertime. But this shows a surface that is really, really flat, shows that gradation is winning here for sure. This slide right here is of the Canadian Rockies, and this shows that tectonics is winning, the mountain building forces. Beautiful slide, Canadian Rockies. Okay, I believe one of the questions you have on Canvas is to describe what an anticline is and a syncline. An anticline is an upfold and a syncline is a downfold. When you put compression on the Earth's crust, it'll fold up like this, like putting your hands on a white tablecloth and bringing your hands together. The upfolds are called anticlines, downfolds are called synclines. So this is the parking lot at Calico Ghost Town out near Barstow. This would be an anticline, a syncline, another anticline right there. Okay, compress the Earth's crust, sometimes it'll fold up, that's an anticline right there. Arches National Park, state of Utah, syncline, anticline, syncline. So syncline is a downfold, and anticline is an upfold. I believe I asked you to talk about the 3 major fault types. So the first type you're going to tell me about is a normal fault. It's caused by tension in the Earth's crust, that means pull apart the Earth's crust, and there's vertical motion. The result is a little cliff here, or a footwall, or a fault scarp is created. Second type of fault you're going to tell me about is a reverse fault. Also vertical motion, but instead of pulling the Earth's crust apart, I'm compressing it together. So reverse fault caused by compression, and it results in vertical motion. You can build up a face of a mountain over time. Strikeslip fault's the third type. That's what the San Andreas Fault is. So you want to write down that the motion is primarily lateral, right? It slides by, right? There's more horizontal motion rather than vertical. Okay, so this is in Palos Verdes. I grew up in Long Beach. Palos Verdes is really close. This is the fault right here. This is a normal fault. This side's dropping down compared to this side. I know that because these folds come in and are dragged down right there. Notice a different color rock on each side of the fault also. So that's a normal fault. That's another normal fault out in Death Valley. This bed lines up with this one, so I know the relative motion is pull apart like that, tension in the Earth's crust. That's another little normal fault out in Death Valley. This is a reverse fault in Death Valley. It sure looks like the Earth's crust is being compressed here, compressed together. So there's still some vertical motion here caused by compression, reverse fault. Okay, this is the east side of Sierra Nevada mountains near Lone Pine. This is Mount Whitney, the highest peak in the lower 48, about 14,494. These are the Alabama hills right here. So the east side of the Sierra Nevada is very steep compared to the west side. So it's been uplifted over the last maybe 15 to 20 million years by normal faults. The mountains are still going up. Gradation is trying to wear the mountains down at the same time. Things like really small glaciers that still exist, but definitely running water and wind. This is the east side of the Grand Tetons near Jackson Hole in the state of Wyoming. Grand Tetons are magnificent. Jackson Hole is a great city if you ever get to go visit it. But the east side of the Grand Tetons has been uplifted by earthquakes also, by normal faulting. Okay, just another look at the Grand Tetons, beautiful area. This is a fault scarp, a little Nura Bluff created by an earthquake. So the mountains went up in about 1971 right here down in Southern California. Went up a couple feet in that earthquake, it looks like. This fault scarp here, this little ledge right here, was created maybe 2,000 years ago. So one earthquake uplifted the mountains this much, but several earthquakes have occurred to uplift an entire mountain range. Horst and grabens are associated with normal faults primarily. So a horst is a block of crust that's gone up between parallel faults. The graben is a block of crust that's dropped down. Those are German words. Horst means eagle's nest, graben means ditch or grave. So this is the Panamint Valley right here. That's a good example of a graben. And these are the Panamint Mountains over here, a good example of a horse. And Jackson knows when I took this slide right here that I was traveling through the desert on a horse with no name. It felt good to be out of the rain. That's corny. Go ahead, next one. All right, this is Death Valley. It's a graben, or technically a half a graben, close enough. So I'm standing on top of a horse, which is the Panamint Mountains, looking down in Death Valley, a graben, looking over at, those are probably the Funeral Mountains over there, which would be an example of another horse. Okay, the San Andreas Fault runs about 750 miles from about the Salton Sea, through the Cajon Pass, through the Tejon Pass near Frazier Park. It goes near Shalom, right? You know where that is, where James Dean kind of bit the dust right in there. Goes through Parkfield, Hollister, and up through San Francisco towards Cape Mendocino. So the San Andreas Fault is a strike-slip fault. The movement's primarily lateral. Sometimes the fault just looks like a valley right here. This is where it's located, kind of in the Palmdale area. But near Taft, to the west of Taft on the Carrizo Plain, it is one big gash in the ground. So on this side of the fault, the movement is going to the northwest at an average rate of 2 to 3 inches per year relative to the North American plate. This is the North American plate, the Pacific plate, the relative motion is like that. These are some historic photos from one of my mentor teachers of an earthquake in Long Beach. I believe the date was 1933, and it's the Inglewood Newport Fault. It's probably about a 6.3 quake centered off of Newport Beach. The Inglewood Newport Fault is a particularly dangerous fault because it runs right underneath an urbanized area. It goes from, obviously it goes from Newport Beach to Inglewood. So this is some of the damage in Long Beach, 1933. Okay, some more damage. I doubt they have the earthquake codes that we have now in buildings, so a lot of older buildings these days get retrofitted, so this kind of damage may not occur. Okay, that was the car I took to the prom, right there. And stay away from brick buildings, okay? Masonry tends to fall in earthquakes. Okay, red tile roofs are nice roofs. They're very heavy though. In earthquakes, sometimes they can pancake the building. That's in Compton, 1933. This is more slides from one of my mentor teachers. This was 1971 in Sylmar near Magic Mountain. You probably know this interchange. It's where the 5 and the 14 actually split, and a lot of damage on the freeways, as you can see. Okay, more damage. Okay, a little fault scarp, little hill or tiny little bluff there created by the earthquake in 1971 on the I-5 freeway. Wood frame buildings are usually very good in earthquakes. They give and they shake, but if you shake them too much, they fall off their foundation. The houses have problems. Again, 1971 Sylmar. Look at the roof of that house. That house is totaled. And another pancake building, right? Red tile roof. This guy used to be about 6'8". That's what happened to him. This was where there were a lot of deaths in 1971. I'm forgetting the name of the hospital. But you can see this is the roof of the hospital, part of it, and this whole section of it collapsed right here. So I can't remember if it was 50 or 60 deaths in this particular hospital. Okay, there's a little fault scarp right there. Again, a little tiny hill created by earthquakes. This was Sylmar, 1971. Now, I took these slides. I was in college. I'm trying to remember. I think this was 1987, and it was in Whittier, and I believe it was a 5.9, no more than a 6.0. But again, brick buildings often take a hit. This is Whittier also in the late 80s. You see the classic Mustang got wiped out there. Okay, more damage right below that brick building. But what a cool Mustang, man. Jackson wants these speakers for his truck that he's getting now, because he's really into 8-track and cassettes, aren't you?
Oh yeah.
Oh yeah. Okay, let's go. Keep going. All right. So oftentimes the front of buildings come off, the facades. This was Whittier, 1989. Damage inside of a building in Whittier. I went behind police yellow tape. Could have been shot as a looter just to get these slides for you guys. Go ahead. I went up and got these slides too in '89. That's the I believe that's the 880 Nimitz Freeway. That San Francisco quake, which was actually centered closer to Santa Cruz. like, it was probably like almost 50 miles, 50, 60 miles from San Francisco, the epicenter. But somebody was trapped under there and they got him out. There weren't a lot of people on the freeways when this occurred. It was right around 5 o'clock, and I think it was game one of the World Series between the San Francisco Giants and the Oakland A's. It was just about to start. So fortunately, a lot of people were off the freeways getting ready to watch the game. So I'm pretty much convinced that this earthquake occurred because the big Dodger in the sky was very upset that there was a Bay Area World Series in the late 80s. That's Hollister. That was on the way up to San Francisco when I took a journey up there after the earthquake. This house had some damage, obviously, in terms of its foundation. This was in Hollister, too, where the facade of the building had come off. And a lot of the damage in San Francisco in this quake was in the Marina District. Marina District's kind of an upscale part of San Francisco. Liquefaction occurred there. If you shake water and sand together, it liquefies, like if you're standing at the beach and the waves crash over your feet, how your feet kind of sink in. That's what happened in the Marina District. Tremendous damage in 1989. Some of the gas lines broke, so I got a shot of that. These buildings, I'm sure, had to be taken down. I know that some they were able to hydraulically jack back up and build new foundations underneath them, but this looks, I don't know if they rebuilt these. These look pretty bad. Brick buildings again. This was in San Francisco. I was walking around some of the neighborhoods in San Francisco, and there was liquefaction on the driveway right here. These notices said this building is not suitable for habitation until cleared by a licensed contractor to make sure it's safe. Okay, I took these slides too. This would now be, oh boy, 1994. Yeah, State Northridge parking structure. It was about a 6.7 if I remember correctly. I-5 was closed for a while. I-10 was closed for a while down near Santa Monica. This is another shot, side view of the State Northridge parking structure. Okay, this is the Kaiser Permanente building. Okay, when I walked around the neighborhoods there in the Northridge area, a lot of the cinder block walls had fallen over. That looks like a carport that got crushed. I believe there were 16 deaths in the Northridge Meadow apartment buildings, if I remember correctly. This was a 3-story building like that one, and it became a 2-story building. The bottom floor was crushed, and you can see what happened to some of the bottom floor. It's like squishing a jelly donut, right? Jelly came out, and the bottom floor came out. The moral of the story is, in earthquake country, you want to live where? On the top floor. This is Paso Robles. This was 2003. I had a home over in Cambria when this earthquake occurred. The epicenter for this was near San Simeon, but it ruptured a fault all the way to Paso, where there were 2 deaths. This is a spring that opened up, hot spring downtown, that was spewing out thousands of gallons of water a day. Okay, this is where some of the damage took place downtown. The deaths were probably in this structure, I'm guessing. I don't know that for sure. But again, this is Paso, damage to brick buildings. A lot of glass was broken. This is the earthquake in Alaska, 1964. I got these from a geology teacher when he retired. This was a 9.1 or a 9.2, the largest earthquake in North American recorded history. This was a monster. The ground shook for 4 minutes. Those of you that have been in earthquakes know 30 seconds feels like an eternity in an earthquake. I can't even imagine 4 minutes of shaking. But only 165 or 8 died. There weren't a lot of people in Alaska in 1964, but check out the cool VW van over there for sure. How do you get into the Denali Theater? How do you go get some home cooking? Look what happened here. The whole side of the street submerged right there. Nightmare earthquake in Alaska. You know, ground opens up. You can see China. Train tracks. I mean, that's a tough one right there. This was a neighborhood in Anchorage. When I was on my sabbatical, I went to Alaska to look at some of this stuff, and there's a park there right now, and signs that talked about how many houses were destroyed. Valdez, Alaska before the tsunami, Valdez, Alaska after the tsunami. So a tsunami is a large ocean wave that can be created by an earthquake, like in 2011, the one in Japan that was so devastating. So this is some of the damage on the ground in Valdez, 1964. And there's some more right there. So I believe that's the last slide. Is that right, Jackson?
Yep.
Okay, all right. Good luck on your assignment. Turn that in. Hopefully you enjoyed the slides.